day, students. I am Mrs. Elaine Ruth A. Olaraza. In today's video lesson, we will learn about the equation of Charles' law under the competency investigate the relationship between A. Volume and pressure at constant temperature of a gas, B. Volume and temperature at constant pressure of a gas, and C. Explains these relationships using kinetic molecular theory. At the end of this video lesson, you should be able to A. State Charles' law, B. Write the equation for Charles' law, C. Derive equations for Charles' law, and D. Solve problems involving Charles' law equation. Let us recall the concept of Charles' law. Charles' law states that the volume of the gas is directly proportional to its temperature at constant pressure. Jacques Alexander César Charles formulated Charles' law of gases in 1787. This is the animation for Charles' law. We can see that we have a constant pressure of 1 atmosphere with a volume of 25 liters at a temperature of 300 Kelvin. A Bunsen burner is used to increase the temperature of the gas. What happens to the volume of the gas as the temperature increases? You can now see that the volume of the gas increases from 25 liters to 50 liters as the temperature increases from 300 Kelvin to 600 Kelvin. Therefore, volume is directly proportional to the temperature of the gas. This means that as the temperature increases, the volume also increases. On the other hand, as the temperature decreases from 600 Kelvin to 300 Kelvin, you can see that the volume of the gas also decreases from 50 liters to 25 liters. This means that as the temperature decreases, the volume of the gas also decreases. The relationship between volume and temperature can now be written mathematically as V is directly proportional to T at constant T, where V is the volume of the gas, T is the temperature, and P is the pressure. Considering the initial and final values of volume and temperature, our equations are V1 over T1 is equal to constant, and V2 over T2 is also equal to constant. Combining the two equations become V1 over T1 is equal to V2 over T2, where V1 is the initial volume of the gas, V2 is the final volume of a gas, T1 is the initial temperature of the gas, and T2 is the final temperature of the gas. This therefore means that the variable with a subscript of 1 is the initial value, and the variable with a subscript of 2 is the final value. We are now ready to derive the equations for Charles' law. Let us start with the value of V1. For the first step, write Charles' law equation. V1 over T1 is equal to V2 over T2. Next, we will cross multiply. So, the equation becomes V1 times T2 is equal to V2 times T1. For step number 4, divide both sides of the equation by T2 to cancel it out. So, we were able to derive the equation for V1. V1 is equal to T1 over T2 times V2. I will show the actual derivation of the equation in a whiteboard. First, write Charles' law equation. V1 over T1 is equal to V2 over T2. Next step, we will cross multiply. Then, we are going to write the product. V1 times T2 is equal to V2 times T1. Since we are looking for the value of V1, we are going to divide both sides of the equation by T2. Then, we can now cancel out T2 in the left side of the equation. So, this is now the derived equation for V1. V1 is equal to T1 over T2 times V2. Next, we will derive the equation for V2. Again, we should write Charles' law equation first. V1 over T1 is equal to V2 over T2. Next, we will cross multiply. So, the equation becomes V1 times T2 is equal to V2 times T1. For step number 4, divide both sides of the equation by T1 to cancel it out. So, we were able to derive the equation for V2. V2 is equal to T2 over T1 times V1. This is the actual derivation of the equation in whiteboard. First, write Charles' law equation. V1 over T1 is equal to V2 over T2. Next, we will cross multiply. Then, write the product. V1 times T2 is equal to V2 times T1. Since we are looking for the value of V2, divide both sides of the equation by T1. We can now cancel out T1 on the right side of the equation. So, this is our derived equation for V2. V2 is equal to T2 over T1 times V1. For the third one, we will derive the equation for T1. Step 1, write Charles' law equation. V1 over T1 is equal to V2 over T2. For the second step, we will cross multiply. So, the equation becomes V1 times T2 is equal to V2 times T1. For step number 4, divide both sides of the equation by V2 to cancel it out. Now, we were able to derive the equation for T1. T1 is equal to V1 over V2 times T2. This is the actual derivation of the equation on a whiteboard. First, write Charles' law equation. V1 over T1 is equal to V2 over T2. Then, we will cross multiply and write the product. V1 times T2 is equal to V2 times T1. Since we are looking for the value of T1, we will divide both sides of the equation by V2. So, this is now our derived equation for T1. T1 is equal to V1 over V2 times T2. Lastly, we will derive the equation for T2. Again, let us write Charles' law equation first. V1 over T1 is equal to V2 over T2. Then, we will cross multiply. So that the equation becomes V1 times T2 is equal to V2 times T1. For step number 4, Divide both sides of the equation by V1 to cancel it out. And this is now the derived equation for T2. T2 is equal to V2 over V1 times T1. This is the actual derivation of the equation on a whiteboard. First, write Charles Law equation. V1 over T1 is equal to V2 over T2. Then, cross multiply. Write the product. V1 times T2 is equal to V2 times T1. Since we are looking for the value of T2, divide both sides of the equation by V1. Cancel out V1 on the left side of the equation. So, this is now the derived equation for T2. T2 is equal to V2 over V1 times T1. These are now the derived equations for Charles Law. Again, I am reminding you that it is important for you to know the units of volume. These are liter, milliliter, cubic meter, cubic decimeter, cubic centimeter, quart, and gallon. And these are also the units of temperature: degree Celsius, degree Fahrenheit, and Kelvin. Please bear in mind this important note that the unit of temperature must be in Kelvin when solving Charles Law problems. To convert degree Celsius to Kelvin, add 273.15. Example, 100 degrees Celsius is equal to how many Kelvin? For the solution, 100 plus 273.15 is equal to 373.15. Therefore, 100 degrees Celsius is equal to 373.15 Kelvin. We'll proceed with the problem solving part. Be ready with your paper and ball pen. Problem number 1. An inflated balloon with a volume of 0.75 liter at 30 degrees Celsius was placed inside the freezer where the temperature is negative 10 degrees Celsius. Find out what will happen to the volume of the balloon if the pressure remains constant. The initial temperature is 30 degrees Celsius. The final temperature is negative 10 degrees Celsius. The initial volume is 0.75 liter and the unknown is the final volume. T1, which is 30 degrees Celsius, is equal to 303.15 Kelvin. T2, which is negative 10 degrees Celsius, is equal to 263.15 Kelvin. The formula for V2 is equal to T2 over T1 times V1. Let us substitute. T2 is equal to 263.15 Kelvin, T1 is 303.15 Kelvin, and V1 is equal to 0.75 liter. So, the final volume is equal to 0.65 liter. We can see from the data that the temperature decreases from 303.15 Kelvin to 263.15 Kelvin. In the same manner, the volume also decreases from 0.75 liter to 0.65 liter. Let's have problem number 2. The temperature of a gas in a 2-liter container is 300 Kelvin. What will be its volume if the temperature is increased to 500 Kelvin? The pressure remains constant. The initial temperature is 300 Kelvin. The final temperature is 500 Kelvin. The initial volume is 2 liters and the unknown is the final volume. We don't have to convert temperature because they are already given in Kelvin. The formula for final volume is equal to T2 over T1 times V1. Let us substitute. T2 is 500 Kelvin, T1 is 300 Kelvin, V1 is 2 liters. So, the final volume is 3.33 liters. We can see from the data that the temperature increases from 300 Kelvin to 500 Kelvin. Therefore, the volume also increases from 2 liters to 3.33 liters. It's now your turn to solve the following problems. Write your answers in the worksheets given to you. Problem number 1. At 320 Kelvin, a certain quantity of gas occupies a volume of 10 liters. What will be its volume if the gas is heated to 450 Kelvin? The pressure remains the same. Problem number 2. At 30 degrees Celsius, a certain mass of neon gas occupies a volume of 30 cubic meters. If there is no change in the pressure, predict the temperature in Kelvin needed for the same mass of neon gas to occupy a volume of 50 cubic meters. Don't give up with these problems because Duke Ellington once said, "A problem is a chance for you to do your best." Be ready with the next video lesson by answering the following questions. 1. Identify the properties of gases. And 2. Explain the different postulates of kinetic molecular theory. Once again, I am your teacher Elaine. See you in the next video lesson episode.